Good morning, good evening, wherever you are, and welcome to episode 61 of the Cloudcast. We're back, and we're coming to you live from our massive Cloudcast studios from Raleigh, North Carolina. Aaron, how you doing tonight?
I'm doing good. It's a really good night. My Clemson Tigers are beating up your Deacons pretty bad right now on ESPN, so
yeah,
I'm good.
It's ugly. So we got some news with you that we'll get to at the end of the show, but why don't we get back into it? It's been a little while since we fired up the show, so thanks to everybody for being patient with us. Tonight we're going to dive into a space that's really, really critical for the web and cloud computing, but kind of new for listeners of the podcast, or at least topical for the podcast. So in the past we've talked about some of the new platform as a service application development platforms, so Cloud Foundry and OpenShift and Apprenda and things like that. But tonight we're going to dive a little bit deeper. We're going to start looking at the concept of NoSQL databases, or sort of non-relational databases. And tonight we've got a really great guest. Our guest is Justin Sheehy, who's CTO of a company called Basho. Basho, one of the sort of up-and-coming distributed system NoSQL databases. Justin, welcome to the show.
Thanks, guys. It's really my pleasure to be on.
So, Justin, for folks that may not be familiar with Basho, or just sort of give us a little bit of background, sort of where your career's gone, and then who is Basho? What sort of technologies do you guys bring to market? What are you doing out in the marketplace today?
Sure. I'm Basho's CTO. Like you said, I've been with the company for our whole existence, which we really, the first few of us pulled together at the end of 2007.
Okay.
Before that, I've mostly done things that are related in one way or another to distributed systems. I worked at Akamai for about 5 years, and I worked at the MITRE Corporation, which is a federal contractor to various government agencies. So a lot of my work has had to do with either really large distributed systems or mission assurance, high assurance kind of resilient systems, things like that. So that's really the kind of work I've mostly done.
Okay. And Basho's, a company. It's a type of company that we're seeing evolving more and more. You guys are a company that makes an enterprise version of a product and an open source version of the product, or at least a similar variation of the code. Talk about the technologies that you guys build and the types of problems that Basho tends to try and solve.
Yeah, sure. So the first product we built is Riak, which is our database product. And Riak, it's a distributed database, meaning that the database isn't on a machine, but on a cluster of machines. And they're all created equal. There's no master, slave, or complicated topology.
Okay.
And it's really all about providing scalability that's just linear, right? If you want more throughput or capacity, just add that many more machines. And about really high availability, and about very predictable behavior. And that's both in terms of performance and what happens in the field under load. A lot of us involved in building it have had to operate large systems and realize that a lot of both new and old data technologies don't really take that perspective into account that much.
Okay.
So Riak we've had now for a number of years, and lots of companies have been using it really happily to get exactly those things: availability, scalability, and so on.
Okay.
But then a funny thing happened early this year, which is that a couple of our customers were saying, well, we're getting into this cloud thing, and we really need object storage, and we're not, for whatever reason, seeing anything that fits our needs. We really want something that's just like our own S3. And after we heard that, the second or third time, the light bulb kind of went off, and we realized that in Riak we had built 80% of that. So we sort of pivoted a bit, not in the sense of recovering from something not working, but just in terms of changing our intended product strategy a little, and built Riak CS around Riak. And so as opposed to Riak, which is a database, Riak CS uses Riak for its data storage, but it's more intended to be run as a service. And it really is essentially a run your own S3 sort of a product.
Okay. So CS being like cloud storage.
Precisely.
Okay. So so you bring up you bring up a whole bunch of interesting things from a technology perspective. So let me touch on the database side of things first. So when you start talking about distributed systems, obviously you're going to start getting into, and we can dive into relational databases versus non-relational. But even at a really basic level, when you're talking about distributed systems, what are you getting into? What are you seeing people get into in terms of, say, like the number of machines that they typically are dealing with in terms of trying to provide availability? And then what do you start to see commonly in terms of like physical distribution? Is it multiple locations? Is it just typically multiple racks for availability, or what's, as you're dealing with some of these, your customers, what does their environment typically look like?
Yeah, it's a really interesting couple of questions. And I think a lot of people get stars in their eyes when they start looking at all these distributed systems and start thinking of, running something, even if they don't know what, on, a whole data center full of machines. And
right.
In reality, especially if you're talking about a database, right, you're generally, you're not Facebook, you're not Google, but you might be a business with a bunch of work that needs to get done. And so while there are some much larger deployments, the average cluster out there of Riak is, I think, somewhere between 15 and 20 machines. And, if you do the math on, packing a few decent modern disk drives into each machine, that's actually a pretty darn large database.
Yeah.
So I think that there's a little bit of a reality check. While there are people that go much larger, both with Riak and with, all sorts of other systems, most businesses today, even in this, big data excitement that's the current trend, wouldn't know what to do with a petabyte of storage if you dropped it on them. So, it's much more common that you see, many terabytes and, a small double-digit number of machines that people really scale out to in a common case. Like I said, there's definitely exceptions, but that's much more common.
Okay.
And so, Justin, tell us a little bit about when it comes to that scaling out concept and adding them. Technically, what happens with the databases kind of growing and shrinking, and what's a little bit of behind the scenes on all of that, technology-wise? Yeah,
that's a great question. So many parts of Riak are shaped a lot like the system that Amazon described in their Dynamo paper. It's since grown to have a whole bunch of interesting differences. But there's a couple of details there that are really important to the scalability aspect. And so one way of thinking about it is that we actually divide up the possible key space of the whole database into a very large number of pieces. And then what we do is we assign all of those pieces to however many machines there are in the cluster. So say we divided it up into 1,000 virtual database pieces, and you only had 2 machines, well, then each one of them would have about 500 pieces. And then as you add machines, because you've already figured out that granularity, those sort of subunits of the database, we simply, as you add machines, they'll take some of those pieces from each of the other machines so that your load can sort of generally spread and gradually spread.
So everything kind of fans out over time.
Right, and then when you take that and you use a technique called consistent hashing, which I think was actually first used at Akamai, where we used it to locate web caches, but it's been used for a bunch of things since then. That allows you to have this indirection layer where you map keys, right, that people are asking for, that people are querying for, to those virtual pieces of the database. So you have this sort of zero-hop routing from any machine knowing where any piece of data is located just by looking it up.
Okay. And when you talked about sort of this transition, if you will, or sort of realization that functionality that was, say, in the Riak code could then be either repurposed or modified to sort of become an object store. It's interesting to me because the more I kind of explore this space, the more I see this blurring between people who talk about their database as a database, sort of in the application sense, and then more so, I'm starting to see kind of people use the terminology that their database really is storage. And and to a certain extent, I guess you could sort of say, well, data lives there. If it lives there, it's storage. But like, what if you were kind of to pull the covers off the system, how much different does a NoSQL database look like than an object store? I mean, are they very, very simple? Is it just how you sort of distribute and replicate data, or like how did you guys kind of come to that realization that you could make that transition?
Yeah, well, there's a few things buried in there. Let's come back later to dealing with the phrase a NoSQL database.
Okay.
But in React's case, what people want out of an object store today, what people say when they would talk about storage in the cloud context, and cloud, almost anything else besides storage, is really been informed by Amazon, right? Anyone that talks about what the market expects out of any element of cloud that doesn't look to Amazon first is missing the point, right? Because that's where the majority of people are now, and so that's what's developing expectations. So people expect the features you get from there, which is actually a pretty simple, really, really limited query model, but the ability to do things like stream really large data files, the ability to set access control lists outside the administrator. This is something you typically don't see in a database, right? You can put something in S3, and then you can set an access control list so that your friends or your colleagues can see it, but no one else can. That kind of little bit of delegated access control. And just the fact that this thing is intended to be accessed over the web, over the open internet, instead of locally like a database. So Riak turned out to be really well suited, and I think some other databases would and some wouldn't, to being the storage layer for a cloud object storage system. Right, because that scalability and availability is something people want if they're going to offer a service like that.
Right.
But we had to build on top of it to get the large file streaming, the access control model, and things like that make it look much more like what people expect when they're looking for something like S3. Okay.
And on top of that, one of the things I hear about React CS, is it is S3 API compatible. It's something that if you're familiar with sort of the public version of S3, this is something that you could easily kind of replace or not have to change your applications. So I'm kind of first of all, is that correct?
Yeah. So okay. that is correct. I can talk about that, but it sounds like you've got an actual question.
Well, so I'm curious. So we've had some folks on the show, like one of the things that we've talked about on the show a number of times is this idea of for some of the people that are building cloud stacks and which API should you write to. You get into these sort of Amazon APIs versus OpenStack APIs and other API kind of arguments. And one of the comments that somebody who was on a couple of weeks ago, a guy named Simon Wardley, sort of said was, he said, look, there's a mindset that says, hey, you can think about APIs as being this great competitive differentiator, but anymore, kind of like what you were saying, is Amazon is kind of the de facto API. At least you look to them. When you guys were thinking about how to design this, I mean, was there ever any thought about you should do anything different to sort of differentiate yourself, or did you just say, look, everybody knows how to write to that. We're gonna use this platform, this community, that people that know how to do that?
Yeah, it was actually really, really obvious for us. That was simply what the market was asking for, and nobody, not a single customer. There's people building their own stuff that might feel differently, but I've never heard a single customer say, don't give me the Amazon API. Simon is dead on here that, it depends on whether you're solving problems for yourself or for the market.
Yeah.
And, if everyone was starting to build these systems at the same time, then innovating at the API might be interesting. But when the majority of use and customers out there are already using the same one, you don't pick it because it's the best. You pick it because it's the one that gives you the least friction to get people to adopt your product.
Gotcha. Yeah.
Sure. Okay.
Sort of the old Betamax versus VHS argument. It's all the players are already out there. There's no point in moving to a different format. So yeah, and then that makes sense. I was just kind of curious what your mindset was in that, because we've heard other people who say, hey, we're gonna try and differentiate based on an API or something like that.
Yeah, I get how that's attractive, but we made most of these decisions by having customers tell us what they wanted.
Yeah.
And it's just that simple. Now, we don't try to promise that we will always do 100% of everything Amazon does in the S3 API. Because if we did that, they could just, wag their tail a little bit every day and we'd never stop. Right? What we try to do is we're extremely compatible with the majority of the API, right? We try to cover that large surface of it that almost everything uses. But, for instance, we don't have the BitTorrent download part of S3. Because customers haven't asked for that, right? So we don't claim 100% coverage. What we claim is really large majority coverage and that it works the way you expect it to if we have it at all. There's actually one time when I got surprised by it very early in our launching the product. Part of how we keep ourselves honest on this is we use third-party S3 tools and libraries to do our testing instead of our own implementations of the protocols. And one of our first customers of this, which is IDC Frontier, which is a related company to Yahoo Japan.
Okay.
One of their executives went and pointed Dragon Disk, which is yet another consumer piece of software that you can point at an S3 bucket, and it's a little bit like Dropbox, but not exactly. And we'd never touched it before. We'd never tried it. It was something he liked. And he wrote email saying, yeah, I pointed Dragon Disk at React.cs, and now I'm storing my desktop files in there.
Cool.
just worked, huh?
That's awesome, right?
Yeah, exactly.
And so we get that effect by using this API that's already so common. We get interoperability with software we've never heard of.
Yeah, that's powerful. That's really powerful.
So Justin, let's talk a little bit more too before we kind of go into NoSQL and some of the other things. That one thing that I've been really curious about with this concept of distributed systems, and I don't know if the model is different if it's React or React CS, but talk a little bit about the architecture of what happens if something fails, right? You talked about, everything is fanned out and everything is stored in all these places, but what if one or more nodes fails? What exactly happens in that kind of scenario?
Yeah, that's actually something that we try to be far more clear and obvious about than lots of other systems, right? You can run lots of data systems across multiple machines, right? People have done sharded, replicated MySQL and things like that, right? The trick is knowing when given pieces fail, what the results are, and how you get back out of that. So one of the things that makes that a little simpler in the case of React is that all of the nodes, all the hosts running the software, are identical within a data center in terms of their role. And I mean, they're all really identical. They're not replicas content-wise. So what that means is you're thinking about those failures gets to be a lot simpler. You don't have to think about different kinds of combinations of, what if a master fails, or a name node, or a slave, or a arbiter, or whatever. No, it's just a React node. And so there's actually quite a bit that we expose to the user and operator to give them tolerances. So for instance, they can choose to have some of their data be available, even in cases when not all replicas of that data can be reached. And by the way, when I say available, I'm a distributed system person. That always means write availability. Read availability is not an interesting problem.
Sure.
I'm being able to change the state of your system. And so one of the things that you can choose to do with React, but you don't have to, is to be able to change your data even when you can't reach all the replicas, which is kind of heresy from a database point of view. But that allows you to have tolerances for certain parts of your application where you would actually rather have some things that are user-facing maybe be a little bit stale instead of having a broken web page or a broken application. And so, with a typical React deployment, for instance, as long as you can reach any one of the 3 relevant hosts for any given piece of data, you can read that data. But you can change that. You can change how many replicas there are. And you can change how big a quorum of those you have to be able to get to consider it a success. So the real answer to your question about what happens for a given number of nodes failing or a given number of hosts failing is you get to choose, right? There's no such thing as a system that never goes unavailable. If all the machines are down, there's nothing happening. But you can turn up the number of replicas and your tolerance for failure, and it's just extremely transparent how many machines will cause what effect when they go down.
Yeah, and that's really nice because really you can plan based on many different factors. What is your comfort level? What is how many hardware nodes you actually have, considering budget, and there's lots of other factors that could go into that, as opposed to a fixed kind of recovery plan or a fixed recovery strategy. I like that. That's really cool.
Oh, thanks. Yeah, it makes it easier to think about. Just decide how much unavailability costs you, and you can spend accordingly.
Yep. I like that.
Very cool. So, so bear with us a little bit. This is going to be kind of way below your pay grade, if you will. But give us, for folks maybe that aren't sort of either hardcore distributed system fan, kind of people, or who maybe have some experience, say, on the Oracle side, SQL side, database side. What's going on in this sort of so-called NoSQL world? What's different about these technologies than people have had in the past with databases? Like, what types of new problems are they trying to solve that they kind of had to come up with these new approaches that various people are building?
Yeah, sure. So I think probably the biggest common confusion in the software industry about NoSQL is that it's a category and that these systems have something in common. Right? Anytime you ask, which NoSQL database should I choose, you're asking the wrong question and you don't know enough about your own problems yet. Because there are no common problems shared by all these systems. They're not actually very common to each other technically. What NoSQL is, if it can mean anything, is it's a movement. It's not a category.
Okay.
What I mean by that, since you were talking about people that are more familiar with traditional databases, is that for the past couple of decades, and that's about the right amount of time. It wasn't always this way, but it's been this way for a while. We've had a bit of what I think of as an architectural monoculture in databases, right? Where Oracle, MySQL, Postgres, Microsoft SQL, DB2, they're all basically the same architecture, right? They're all essentially the same system with different feature checkboxes. But it's not the SQL part's not the interesting bit. It's that they're all row stores. They all have the same data model. They all have the same replication model. And so we got into this weird situation where anytime someone started a new big software project, they'd make a whole bunch of architectural decisions, right, about programming languages and frameworks and operating systems. But they didn't make any architectural decision at all about the database because they were picking from a set of essentially identical things. And then what I think actually broke this open and created room for this movement was the Dynamo paper, but not because of the technology. When Amazon published that paper in 2007, right, and Amazon is not a company known for wasting money, right? There's a paper that said that a bookseller, right, this is pre-AWS taking off, a retailer that's really cost-conscious had to write their own database to solve a fundamental business need around their shopping cart. And that said to a lot of people that that one architectural choice, that one size fits all, wasn't actually enough. And so now there's this movement going on for the past couple of years, reject the idea that you should always make that same set of choices. So the only thing that all these NoSQL databases have in common is that they're all different in some way from that set of architectural choices that are shared across MySQL. So what they're good at varies widely, right? Some of them are all about making it so the developer can start writing a program against it in seconds or minutes, but have nothing to do with scalability or availability. Some others, like React, are the other way around. They're not really about making it easier to write your programs. They're making it easier for you to write scalable, robust systems. And so not any set of technical choices that are shared across all of NoSQL.
Gotcha. So, okay. So, it's one of those things that almost sounds like it ought to be sort of a like a no Oracle movement, or like, sort of like you said, it's the not the old sort of architecture, not same decisions movement. So, with that in mind, seeing that you could make a list of the guys, the companies that are for better or for worse sort of lumped into that NoSQL. What are the types of problems then beyond that old model that people are trying to solve for? What are the types of application problems, types of business problems, or even just data set problems that these newer approaches, and like you said, they're not all the same, but what are the types of things that they're able to do or flexibility you have that you couldn't do in the past?
Sure. So, one thing that's worth getting out of the way before we talk about what it really does for people is should point out that this stuff is new and shiny.
Yep.
And lots of people do say, oh, I need to go pick a NoSQL, and do pick one. And so there is a lot of use that, I think would be just as well served by Postgres. And that's used across almost any, and that's just an example, Postgres, Oracle, pick your, pick your standard RDBMS. And people choose all of these things, in some cases because they're shiny and it's the thing their friend told them, you'd better learn this or you'll get left behind. But that's starting to fall away now a little bit. So there's a bunch of different problems, right? Some of them are about easier data modeling, right? So for instance, the Neo4j guys will tell you all day, and they're right in some interesting ways, about how so many software problems are really graph problems in terms of their data structure. And so if they give you a database, you describe all your data in terms of graph shapes instead of table shapes, you can express things in this way that looks like the circles and arrows you drew on your whiteboard. So in that case, it's really all about a data model. In some cases, like say MongoDB, what they really used was this query model, and actually really more the API that is just so incredibly simple to use, right? So within 20 or 30 seconds of turning it on, you've done a successful query. You can't get that even with MySQL or Postgres, and they've really succeeded wildly at that. And so that allows developers to start building things before they think about their database. That's a big deal. With some of the sort of more distributed systems-oriented things in there, like Riak and Voldemort and Cassandra and things like that, it's really people's need to survive either as they grow or as they have really high availability needs, which is more and more common now, right? Applications simply require that more for lots of reasons, just given the demographics and market nature of the web. So all different kinds of problems, right? About how you think about your data model, how you might choose not to think about your data model, and how you keep operating under scale and load are all things that people are solving with these.
Okay. So when you guys are out talking to customers, or you're trying to, kind of guide the community, in essence, I think what I'm hearing from you is you're never talking about NoSQL. You're looking for people that are basically coming and saying, look, I have problems that, I hope, or I think, a distributed, highly available through distribution, highly scalable, linearly scalable model. That's the big problem that I have. Can you guys help me? I mean, is that more along those lines? That's the discussions you're driving. That's where you spend your time.
Yeah, that's exactly right. We're not trying to sell NoSQL. There wouldn't be much point in that, since like I said, there's nothing it all has in common. And it's a silly name, right? Nobody thinks that name makes sense, but it's the one we've got, right? There's, trying to come up with a better name than that, would be almost as bright as trying to use a different API than the S3 one, from my point of view. In either case, it's the one people are using.
Okay.
But no, that's exactly what we go to people and say, hey, if you have this set of problems, maybe we can help. And that allows us to really quickly qualify whether someone needs what we're building.
Yeah. And
cool.
how do you typically know as you're talking to people that maybe they've crossed over that threshold, or that they have that problem? I mean, let's say I'm a current application developer, or even a current database. Like, what are the types of problems, or like what might trigger you to go, I mean, like, here's the problem. I could think about it differently if I'm willing to try something else.
Yeah, absolutely. There's actually a bunch of really useful flags that help us see that kind of thing. One of the most obvious ones is that if you look at someone who has a typical relational database, again, it doesn't matter whether it's MySQL, Postgres, something else, and they've denormalized almost all their data in an effort to shard it better or replicate it better or something like that. That is usually a pretty good flag that they're both prepared to think about something that isn't queried all the way like a relational database, since they gave that up when they denormalized. And that a lot of the time they did that in an attempt to try to solve some of the problems we solve for them out of the box. So that's an example, right? When someone's going to the work of taking all their data and storing it in duplicate ways to make querying easier so that they can do one lookup at a time and things like that. Another useful flag is when they might have a typical relational database, but they've put, layers in front of it that make it so that they're really only accessing it in a much simpler way, again, to keep the load and pain of scale or availability off the relational database. The number of layers they've used to shield their actual database from themselves is usually a pretty good flag, too.
Okay. Cool. So Justin, so a couple of weeks ago, Basho hosted an event, RICON. And so, again, kind of to further extend the talking to customers, and what are some of the kind of unique insights or key messages or core learnings that kind of came out of that conference?
Yeah, so personally, the biggest thing I saw by it was, it sold all the way out, and then some. We had to have a bunch of our folks, sort of be ready to not be present in order to have the rooms be legal. And that people were hungry. People really
fire marshal kicking people out, huh?
Yeah, well, they didn't actually kick people out, but maybe they should have, in order to be doing their jobs. But it's fine with us that they didn't. But what that really said was, there was a real appetite for a distributed systems conference, for a practical, no bullshit, here's what people are doing in distributed systems today. And I think what that really says is that more and more of the problems people are solving today, whether they realize it when they start or not, are distributed systems problems, right? If you're building something in, name your favorite cloud environment, either you've got a distributed systems problem to solve, or you're benefiting from someone that did, or more likely both. But one of the things that I think a lot of the attendees got out of it too is that, there's still a lot of really interesting work to do here in the, overlap of practically making things work, but also, right, really figuring out actually new things. If you look at the talks that, for instance, Joe Hellerstein and Eric Brewer, both of the talks on CRDTs, which are a sort of special kind of data type that's really good for high availability. There's a lot of this stuff that, you might think of as coming from, theory land, but that people out there building things at companies like, Twitter and Clipboard and things like that are hungry for. So, what it said to us is this is something that matters that might have been getting neglected from a community point of view, not by us, but by everybody.
Yeah, no, that's powerful. And from all the feedback that I've read about the conference, folks like the fact that it wasn't, obviously it's the first show for you guys. It's still new, but it wasn't driven as being a Basho-centric show. It wasn't sort of that vendor-centric. It was folks, really kind of interested in distributed systems, looking to have conversations, looking to share. So that's really powerful. While you guys are there's an arm of what you do that's for profit. There's also an arm of what you do that's community based, right? So you've got to be able to stay connected with being flexible enough to learn from the community, to give back to the community and stuff like that.
Yeah, absolutely. We're an open source company. We're a very community centric company, and this wasn't. I really think this wasn't in any way something that came across people as like a vendor trade show. Yeah. Those can be good too, but that wasn't what we wanted to give people. If we had nothing to do with it, I know that I and a bunch of other folks that I work with probably would have paid our own money to go to this conference, and that to me is the biggest marker of we probably did the right thing.
Very cool. Now you guys is intention to keep it going, make it an annual event?
Yeah, we didn't call it, we tried most of the time to not say anything like first annual because that sounds a little funny until you do the second one. But yeah, that's the idea is, we wanted to see how it went, but it went fantastically. So yeah, the intention is definitely to keep it going.
Very cool. So, real quick, we're sort of getting close to. We should probably start wrapping this up. So, last question, and we never try to put anybody on the spot, but it's always interesting. When, like you said, when things are new and things are shiny, and people are kind of learning some things. So, a couple of months ago, you guys came out and you created a little bit of a riff. I don't think it was necessarily on purpose, but you talked about extending React support to CloudStack, to the Apache project for CloudStack, Citrix CloudStack, and it was at one of those times when the OpenStack community was very kind of touchy about did you pick one? Did you pick another? Trying to position themselves one versus the other. As a company, as a database company, I would think you guys need to be as flexible as you possibly can. Was this really kind of making a statement, or was this more, look, we'd love to work with CloudStack because it's got momentum, and we'll work with OpenStack, and we'll work with Eucalyptus, or is there kind of more from a technology perspective that would lead you one way or the other?
As much as you might have seen something like that as, picking a side, it's really a lot simpler than that. Like you said, we're a database company. We provide storage. It's fundamental infrastructure, and it would be silly of us to make enemies or to choose not to work with everybody. One of our biggest deployments of React CS, in fact, is running in conjunction with OpenStack Nova, the compute part of OpenStack. And, we intend to keep supporting things like that as well. What this was really all about with CloudStack was really just about pointing out that we found this very complementary match, this very easy situation where you have products, process, and people that are all really complementary, right? You have a compute product and a storage product. You need both for this infrastructure as a service. We both used the Apache license for our open source work. That made it easy. And there was a team that was very easy to talk to and work with, both people in the Apache side and in Citrix. And we have some joint customers and users. And so between all those things, it was just really easy for us to say, we're going out of our way to work really well with this system. That's not at all the same as saying we're not going to work with something else. And in fact, nothing could be farther from the truth.
No, that makes sense, and we're in still such early days with all these things that it absolutely makes sense to be able to work with as much as possible. With that, I think Justin, this has been very, very interesting to us. I think obviously the technology can get pretty deep, but thank you so much for the time tonight. Real quick, Aaron, before you sort of wrap up the show, you got a little bit of news that folks may be interested in.
I didn't know if we were going to bring it up or not, but yes, absolutely we do. I am as of this week unemployed, but as of next week, I actually it's funny you bring up the Citrix and the CloudStack and Cloud Platform at the end there, but I actually start in 2 weeks now. I will be running technical marketing for Citrix for all of their cloud products. So I'm heading over there and really looking forward to it.
Very cool.
So you'll be working for Peter then?
Yes.
Excellent. You're going to be joining a heck of a crew.
Yep. That's the plan.
Very, very cool. So congratulations. And,
Thank you very much.
As we've always said, we do the show pretty much, vendor unbiased, technology unbiased. So, some folks have asked if you're still going to do the show. That's the plan. And the intention is we will still have guests from all walks of life and all sorts of technology. So folks don't need to worry about that. Peter's been a guest on the show. He's always been very, very cool. So I don't expect that to change at all. So, Aaron, why don't you take us home, wrap it up a little bit, and we'll call it a night.
Absolutely. So we are out of time for this week. So, Justin, where can everyone either follow you or find out more about what's going on with Basho or any of your products or the community?
Sure. So Basho is at basho.com, and we are all over, Twitter, and we're in IRC on the React channel on Freenode. It's pretty hard not to find us, whether you're looking or not. I'm really easy to find. I'm Justin at basho.com. I'm Justin Sheehy on Twitter. If you're not coming across us, then you've got your eyes closed.
There you go. Cool. All right, so if you like the show, please tell a friend or leave us a review on iTunes. You can also follow us on Twitter at @TheCloudcastNet or on the web at thecloudcast.net, where you can find links to everything Cloudcast. That's it for this week, and thanks for listening.